Hello and welcome back to another video. Today we have something different to talk about. I have just purchased these two boards. Okay, this and this. They came as you see them, no instruction manuals, nothing. Now, what are these two boards? These two boards are called Decoy PD controller boards. Okay, so what these Decoy PD controller boards do? In order to understand, we need to understand how the USB-C PD controller works. So in here we have a 60-watt charger, which is USB-C, and if you see, it can handle multiple voltages: 5 volts, 9 volts, 12 volts, 15 volts, and 20 volts. Now, how does this charger know when to switch from 5 to 12 to 9 to 15 or to 20? So I have in here my Xiaomi screwdriver. Okay, now let's plug this into the main. Okay, we have the cable in here and we have a meter in here. Okay, USB-C meter. So we plug this in here and you can see the meter, it doesn't even come on. Now if you plug it into a USB-C which can handle PD communication, you see is now 5 volts. Why is 5 volts? Because this screwdriver is 5 volts. This is what this screwdriver needs, 5 volts. Now, if I connect, say, my phone, I don't know if you can see, but now is 8.85, 9 volts. Okay, let me see if I can zoom a little bit. Okay, I don't know if it's better or not. Let's see now. Okay, you see 8.85. Okay, so you see the adapter is switching, but how? Now inside the adapter is a controller called PD controller, right? PD stands for power delivery chip. Okay, power delivery controller chip, and this chip handles the communication with the devices. Why this need for such device? Why just plug it in a laptop and 20 volts and that's it? Because the USB-C is a universal port. You can use this for charge the laptop. You can use this for a keyboard, a mouse, a monitor. You can use this for a number of devices to connect your phone. You can use it for a number of devices. So there has to be some sort of chip which handles the communications. So when where's the screwdriver? When I connect this to the screwdriver, by default the charger sends 5 volts. That's the minimum requirement, 5 volts. Along with the 5 volts, it starts a whole communication, right? So now the charger speaks with the PD controller, with the power delivery management chip inside the screwdriver, and they talk. So the charger sends a hello, I'm a charger. What are you? The PD controller from the screwdriver needs hello, I need to charge. So I need 5 volts. And then the charger switches to 5 volts or if it needs more switches to more. If there is no such communication between these two, it won't even start. You see, there's nothing now. There's not even 5 volts, no 3 volts, no nothing. Until you plug it in and they start talking, there's no voltage at all, right? So you might be thinking, wow, this is really great, but it's not. Especially for laptop, is a step back. Why? These chips fails a lot, right? Unfortunately, these chips are programmed for this board. So unless you buy a chip that comes from a board the same that you're trying to fix, you are not going to fix this laptop, because you find the chip, you buy the chip in AliExpress, $5-10, and then you solder it in, and surprise, it's not working. Why is not working? Because the chip is blank, it has no memory, it doesn't know what to do when you connect the charger. This software is not even available from the manufacturer. So you see, it's meant to just die. It dies, it dies. Now you might be thinking, well, it doesn't matter because we have these little devices which you just connect it in and switch the voltage. And this is where these boards come into effect. Now we have these two boards which are doing the same job. One is smaller, one is bigger. This is bigger because it has these switches in here that allows you, let me see if through the microscope maybe it's better. Okay. Yeah. Okay. So we have these two boards, right? They're doing the same thing. One is smaller, one is bigger, right? This is bigger because it has these dip switches in here which you change to change the voltage. Then you have the output in here. So you have the input from the charger. Then you switch in here whatever you want, and then you have the output. This one, you have the output in here with plus, you see, plus, minus. And there's no dip switches because this one uses these bridges in here. Now, for a test point, from the test point of view, if you're using it to test devices, now this is better because you can easily switch. For a device that you will permanently switch it to 12, 19 or whatever you want, this is probably better because you make the bridges and you're sure that these are there forever. They're not going to change, right? So you're not going to have a surprise that one day by mistake you done this and you switch the voltages. So this is permanent. This is because it's so small, you can even after put like a shrinking tube on top of it, and that's it. Now, what these boards has, nothing. It's just the PD controller. You see, this is the PD controller. This board has a, let's see what PD controller we have in here. This is marked HUSB 238. Right here, you can see it. Now this is the PD controller. This is what handles the communication. Then you have a few resistors in here. Then you have a capacitor, and that's it. This is the same thing. We have the input USB-C, then we have the dip switches, then we have the output, and then we have in here the PD controller. Now let's see what PD controller we have in here. All right. Then we have few resistor, we have an LED, we have a bridge resistor in here, and then we have this capacitor. So really not much to it. What it is the PD controller. Now, why you need this? Like we've seen, you plug the charger, nothing happens. So how do you control this? Now, it didn't come with any instructions, but I did found the instructions. So in case you're wondering, now this is the instructions for this one. Now let's go back under the microscope and I'll be switching the voltages, these switches in here, and see what we get. So we plug it in, they're all down. Let me turn down the light a little bit so we see. With all down, we have 5 volts. Now they said first down, 2 and 3 up. Let's remove it like this. Let's plug it in. 5 volts. Now they said all 3 up, it should be 9 volts, right? So we have all 3 up. If we plug it in, we get 9 volts now. So in here, in the on the output, if you measure, we have 9 volts. Let me do it. So this and this, there is 9 volts, 9.091. Exactly what it shows in here. 9.08. Perfect. Now the 12 volts, let me disconnect it. The 12 volts should be 2 up and the last one down, right? 2 up, last down. This should be 12 volts. And this is 12 volts. Now we have in here on the output 12 volts. Now for the 15 volts, first up, 2 and 3 down. Now we should have 15 volts now. Let's see if we have 15 volts. And we do have 15 volts, you see. Now, and for the last one, the 20 volts, first up on, second off down, third on up. So if I plug it in now, we have 20 volts. So this one works fine. Now you see you have an LED in here indicating that the board is powered. This PD controller doesn't get any hot. It's nice. These legs may be a little longer. We can trim them. But it looks nice, right? So now we have 12 volts in here. Say you have a laptop that is 20 volts only, or a device that it needs 20 volts or 15 or 9 or whatever. For whatever reason you want 12 voltage in here, you can even get a cable like I have in here for the laptops with multi adapters, and then create your own PD controlled laptop charger, right? So this one is working. Let's see this one. Now we have this one. Let's plug it in. And by default, with nothing connected, it's 20 volts, right? Let's see the configuration for this. Again, it came with no instruction, but I did found something. So here is the something. So 20 volts, nothing, no bridges. 15 volts when we bridge the last one. 9 volts we bridge these two, and 5 volts we bridge the first two. Okay, let's do it. So you see we have 20 volts now. Let me go back under the microscope. You can see it better, right? 20 volts now, and there's no bridges, just like they said. So let's remove the charger and let's bridge the first one. Okay, let's do it. So we have to bridge. Okay, the first one, right? Okay, let's do it. So if I now bridge this, right? You see it's bridged. You see the first one is bridged. Now from the instruction, when you bridge the first one, we should have now, let me go back up, we should have now 15 volts. And we do have 15 volts. You see, we just bridged that one. Now let's remove it. Now since we already have bridged the first one, let's bridge the second one. And when you bridge the second one, you lower the voltage to 9 volts. Now we just bridged the second one. You see, the second one is bridged. And if I plug in this USB-C meter, now we have 9 volts. Okay, now let's remove the first one. Okay, we don't need the first one anymore, so let's take a little bit of wig and just wig this first one. Okay, you see, no more bridging here. Now with only the middle one bridged, we should have now 12 volts, right? Let's have a look. Let's see. So connecting the adapter, we should have 12 volts, just like it says on the manual. 12 volts. Now we've done 20, right? We've done 15, we've done 9, we've done 12. Now for the 5 volts, we need the first two bridged. So now we're gonna go here and here. Right? So we bridged the first one and the second one. You see they are bridged. Now if I connect the adapter, there's no explosion, no big bang, and we have 5 volts. Now if I check with the meter, and you will have to trust me on this, right? From the plus to here, we have 5 volts. And here we have 5 volts. So these are together, right? Yeah. These two pins are together, these two pins are together. So now we have 5 volts. This way you switch, you see, with these 3 rows of pads in here, by shorting them in a specific order, you can change between 5, 9, 12, 15, and 20, right? Now if I remove these bridges, this is gone and this is gone. You see how easy? Yeah, right? Now let's clean it a little bit so we've got nobody complaining. So they are, you see, there's no more bridges. Now we should have 20 volts, right? And we do have 20 volts. And if we check with the multimeter, now you're not going to see the multimeter, but you're going to hear it when it beeps. That is over 9 volts. You hear it. Now the multimeter shows 20.150. Let's see this one, what it shows. 20.14989. So yeah, it works great. So what's the utility for this? First, you want to check if an adapter works fine, if it switches between different voltages just fine. Second, you want a specific voltage, you want to use this permanent in a circuit, you can just change the pins and the dip switches in here, or change the pins in here, and That's it. And the last utility for this is if you want to repair like a circuit. Say you have a device that uses 12, 19 or whatever voltages, and you have the connector broken, you can just put this inside, change the voltage, and just run cables to whatever they has to go, and that's it. Will this work to fix a laptop? I'm sure there is someone in there now thinking, wow, now this is really great. I have a laptop with a USB-C PD controller broken, and I'm going to fix this. I'm going to just remove the connector from the board and just glue this in there somehow, take 20 volts from here. Well, it's not going to work, right? Why is it not going to work? Well, it's not going to work because the laptops that has PD controller on the board usually have more than one PD controller. And not only that, the PD controller is the chip on the motherboard of the laptop that handles the communication with this chip, right? That PD controller also talks with the EC chip, which is the input-output communication of the motherboard. Now, if the EC chip can't communicate with the PD controller on the main board, it will not allow the laptop to start even if you power it by 20 volts. It will not charge, it will not start unless you fix that PD controller on the board. So that's a bummer. Now, like we said, usually the laptop has two USB 3, 4, whatever USB ports they have. Each of these ports has its own PD controller. Each of these PD controller communicates with the EC chip. If one of these PD controller, usually it's not like that. Usually one PD controller fails, then you have another PD controller in here. If this PD controller works, then this port which has the failed PD controller is not going to work. This port is going to work, right? But there are some laptops like HP's, all the Apple ones. If one of these PD controller fails, none of them works, right? So one failed, all gone. You can repair the PD controller on the laptop motherboard. Like we said before, unfortunately, that this chip is programmed with a specific software for that board. So you will need to find a broken board, donor board, and remove that PD controller and swap it into your board and hope for the best. I mean, you could just buy a board that has the same problem like yours. You can convert a standard jack connector to one of these connector in a laptop. I mean, so you see we have this board, it's a Lenovo board, right? So this has this connector in here, and what you can do, you have in here 20 volts. You see, let's go under the microscope. Right, so this is the connector. Now you have two red wires in here, two black wires, and there's another wire in here. Now, if you put this, say somehow you glue this in here, right? You take the plus from here to here, you take the minus from here to here, right? And you give it 20 volts. Is it going to work? Well, partially it will work, right? Why partially? It will work, but it will not charge. Why it will not charge? You see, there is another pin in here. You have plus, you have minus, and then you have this, which is the AC detect connect pin. This is the middle pin in here, right? The pin here inside is this one in here. Now this pin usually have a small voltage, 1 point something, 3 volts. I've seen it up to like 5 volts. And this is only communication. Yeah, right. Now the BQ and EC chip check this pin, and if this pin exists with the specific voltage and resistance that the manufacturer set it assumes that you connected a proper charger and you will let the laptop charge. If this pin in here it doesn't exist, then you will not charge. You will power it on, you will not charge. So by simply connecting plus from here to here and minus from here to here, you powering the laptop, but you're still missing this voltage in here. So you will need to add a second power supply, little power supply or something, to trick this pin in here, so the motherboard can think that the charger is connected. So it's not that easy, right? Unfortunately. So this is the type of situations where this will work. Say you have something like this, right? Or say you have a dumb, let me go back to the top view, device like this. I think this is not PD controlled. Let's see. Yeah, see, this is not, this doesn't have a PD controller side. It has a USB-C, but there's no PD controller in here. So if you plug it in, because there is no communication, it's not charging. If I plug in a regular charger, you see it's charging. But if you plug in a PD controller charger with multiple voltages, you will not charge. Now, we set 5 volts in here, was whatever. You can set this to 5 volts. This needs 5 volts to work, right? So let's see what was 5 volts. 5 volts was first down, second 3 up. Now from here you can come with another USB-C cable. You cut the wires, you just take the red and black from here, connect them in here, and then connect it in here, and you have your own charger. You don't have to carry 2 chargers with you, right? So this is the situations in which you need this, but it's great for testing. It's a great device, right? It's amazing. Okay, so let's do a little experiment, right? We have this in here, and let's see how we do it, right? Alright, so we have this, right? Now let's use this. Let's see. We're gonna use the red as plus, and we're gonna use the blue as minus, right? Okay, let's see. So we need a this plus, right? So which one is plus now? Well, if you don't know which one is plus and which one is minus, there is no need to panic, right? What we do is we take the multimeter and we put the multimeter into the beeping mode. You put one probe on the USB-C because this is grounded, and then we test. You see, this is minus, this is no minus. This is minus, this is no minus. And if we check the resistance, this is 0.2 ohm. and this is 6 kilo ohms. So which one is which? Okay, this is plus. So let's connect the plus first before we forget which one is plus and which one is minus. Okay, so let's trim a little bit. This was plus, right? Okay. Okay, plus. If that's plus, this means that this is minus, right? Has to be, because there's no other way. There is no other way. So we have this. This is so beautiful. I think when all were down, well, I forgot this. How was this? So 20 volts was up, down, up, up, down, up. Okay. Now let's make one of the cables. No, we're not going to make it shorter because we are going to connect it in here. In here, you see it's marked plus minus. I don't know if you can see it, but it is marked plus minus, right? You see plus minus. Okay, so the plus one, which is this, goes to the plus one, which is this. You see, this goes in here. You see, okay. And now we are closing this, and now this goes in here. And this is minus. Okay, not the best job in the world, but it's okay, right? Now, if we put the meter again, nothing, zero. We connected in here, and it's 20 volts, you see? There's no smoke coming out, and do we have 20 volts in here? Wait, I have to put this on voltage. 20 volts. Ah, this is beautiful. Now, can we test this? You say, yeah, of course we can. So we have this laptop in here, right? Let's find the connector for it. Let's see if I have the connector for this. Oh, maybe this one. Yeah, there's the one. Let me put this all back in here. Okay, let me take this other board away before I lose it. Now let's measure again, just in case, right? So black outside, red inside, 20 volts. Okay, now if you put the connector in here, plug it into the laptop, is it charging? Yeah, it's charging. You see, you have the charging light in there. Can I turn it on? Yeah, check out. 420 milliamps. So this depends. It means that this connector, this laptop doesn't have a charging ID pin. You see, 0.42 amps, 20 volts. This is one use for it. And this is low. Come on. 0.64. Let's see, is this? It's hot, but nothing to worry about. Let me take the thermal camera and we have a look. Let's see. Well, you see, the battery, it's 0%. Let's see, 0%, and it's charging. So we're just gonna leave it like that for a little bit and see if it's charging. And if we look at this, right now with the 20 volts and with the laptop is about 60 degrees, right? The PD control is about 60 degrees. Let's leave it a little bit until it goes to like 1%. And then we'll try this other one and see if this does better. You see the battery is 0%, so it's obviously taking power from this adapter. If I disconnect this, you will just die, I think. Shall I do it? Let's wait until it goes to 1%. This is 66 degrees now. It's not warm though. I mean, it's decent. Zero 0.24, 25. Okay, let's leave this to one side like that, right? And right, let's prepare the other one. Let's prepare this one. Okay, we'll do the same to this. Okay, let me get two wires. Okay, so we have these two wires in here. Now let's see again which one is plus and which one is minus. Wait. Minus, minus, plus, plus. So red in this side, right? This is even marked, right? We have a plus and we have a minus in there. Now, okay. So let's put a little bit of blocks in here, right? And then we put a little bit of solder. And we're gonna bridge these pins, the two minus together. If we can, yeah. And these two pluses together. Like this. Now we're gonna put the plus in here. And we're gonna put the minus in here. Right, so now we have to bridge this for 5 volts. So let's see which one was 5 volts in here. It's 20 volts. So 20 volts is nothing, right? So just as it is, we get 20 volts. Right, so let's remove this from here. Well, move this from here. And let's connect this in here. So we said plus is this one. Right. Minus is this one. Okay, minus is this one. And wait, we have something here. Okay, there was something inside there. Okay, so we have a charger. Plug in the charger. $20, no explosion, no big bang. Let's have a look. Wait, I need to put this on volts. So we get 20 watts. Now the other one got to about 66 degrees, right? Now let's take the laptop back. Now we have 20 volts, 0 amps, right? Wait, where's the connector? Right here. 20 volts, 0 amps. 20 volts. We have red light, charging light. It's also red in here. But it's not charging properly. I think this battery is way too discharged. Let's try to push it a little bit. Let's put this in here like this. I don't know if you can see it. Can you see it? Yeah, maybe. Well, let's have a look. So when the laptop is so low, it will take some time until it reaches a minimum before you will start charging normally. Now, assuming that battery is not locked already, what we're going to do now is we are going to push some current into this battery and we are going to force it to start charging. If this battery is locked, then it's game over for this battery. Why am I doing this? I mean, this was not the purpose of this video, right? So before I remove the SSD, unplug the power, remove the SSD, right. Now let's check this battery, right? Now this battery should have 15.2 volts, fully charged 17.2. So what do we have? We have 0.3 volts. Man, this is bad. This is really, really bad. Now let's push some current into this battery, right? We're gonna set the power supply to about 15 volts, right? Now we're gonna put the ground on any ground in here now, and we're going to put the plus. Let's get the good ground, and we're going to get the plus into the red cable in here, and now we're going to start the power supply. I think it's charging. $46 milliamps. Man, this is really bad. I don't think this battery is charging. Okay, let's lower this to 15, right? And let's plug the adapter now. Let's see. Well, it's at 1 volt now. So we did something. I just think we have to leave it longer. I think we can still charge this battery. It is taking some current, right? It's taking about 40 milliamps, which is really, really, really low. Really low. But you've seen the voltage going up from 0 to 1 volt. I think it's so discharged that it takes longer. So with the power supply set to 17 volts and a limit of 2.6 amps, it takes about 40 milliamps. If I remove the power supply, plug this thing, the charging light came on, and we have the same, the 40 milliamps, right? Now let's try to power it on. Let's see, 300 milliamps is on. And let's see. Oh, I removed the disc. And let's see how hot it gets this. So this is much better. It's about 35 degrees, but we had it running on Windows the other time, right? So let's put the SSD back and power it on. Okay, let's just put at least one of these screws, right? We don't want this SSD to come out while we're playing with it. Let's put the other one. Okay, so 20 volts, 0 amps, right? Plug it in. 20 volts, supposedly charging, takes about 40 milliamps, same as the power supply. Now, is this voltage goes into the power supply, into the battery, or is this voltage taken by the board? So if I remove the battery, now this voltage is taken by the board, right? I think I have another of these batteries. Let me see. Removing the battery has no effect whatsoever. So either this has a charging ID pin or the battery is dead. Now I do have another battery. Let's see, this one. Ah, yeah. You see, this battery is charging fine. Check this out. 1.28 amps. So this battery is probably locked. We'll have a look in another video. Or the fuse, we'll check the fuse. 1.3. So this battery is good. You see, check this out. I don't know if you can see. Now this this connector is not the best. 1.3. If I remove the battery, it's gone to 0, you see. If I plug the other battery, which is dead, 40 milliamps. Well, so we know the battery is the problem, not the charger, right? Now let's power on this laptop. Okay, it is on, right? What we want to see is the heat that this board generates. And I can see 37.3. Is the laptop on? The laptop is on. The battery is still on 0. I think this battery is dead, right? Wait. It just started charging. Check this out. 1.44, 1.3. I think the little current we pushed into the battery before, we just revived this battery. We just brought it back to life from the dead. This battery is now alive and kicking. Anyway, we want to see the temperature of this thing. 37 degrees. The other one was 65. So this tiny board is actually a lot better. Yeah, there's no heat in here. The other one was hot. 1.31. Man, we brought this laptop back. This was dead like a rock. Let's see if it goes to 1% at least. 1.35, 1 amp and a half. This is beautiful. Come on, 1%. Come on. Look in here. 1.3 amps. While this is sort of charging, I don't know if you can see it. You see better, right? Let me focus a little bit on that. That's it. 1.35. Well, while this is charging, let me clean a little bit in here, remove the power supply cables. It's definitely charging now, right? I mean, 1.3 amps. This is brilliant. Let me check now. 1.68. Let me check now the voltage on the battery. The battery was 1 volt before. Yeah, it's going up. 15.19598, 15.2. This is beautiful. 15.218, 20, 23, 24, 26, 27, 30, 33. It's charging fine. We rescue this battery. Oh man. Still 0. It needs to go about 16 volts, right? But now it's charging. Now it's charging fine. Let's see if it shows in here the charging, or it's only showing the discharging. Well, it is charging now, right? It needs a bit of time. Let me check again this PD controller. $37. So between these two boards, the little one is the way to go. Check this out, 2%. We fixed this battery as well, you see? 2 in 1 in this video. Come on. This has to be worth a like at least. You see? You tune in for a PD controller check and we're charging batteries now. Now let's put this aside like that to charge for a little bit, right? And they use this thing to charge what? Right, we had this thing in here. Now this thing in here, I just lost that. This thing in here, plug in this thing, like this, like that, and now it's 20 volts. So how was the 5 volts? Can't remember. So the 5 volts was, it's disconnected, down, up, up, down, up, up. Now we have 5 volts. Okay. So you will think, why we need the 5 volts for? Now this is a 5 volts USB-C drilling thingy pen, right? Now this charge 5 volts. Now it is USB-C, but if I plug the charger in, you see it's not charging. It's not charging because this doesn't have a PD controller inside. So the charge is trying to speak with it. It's like, hello, hello, anybody there? Anybody there? What do you need? What are you? You need charging? How much? How much current? How much voltage? And this is like nothing. So this is stopping the charging. Okay. Now we have 5 volts in here. How are we going to do this? So we're gonna plug this in here. I need a USB-C that I can cut. Where? Here. Look at this cable. Now, let's cut this cable, right? So we cut this cable. This is one of those chips only charging cable, right? This is what you want. You don't want a nice, beautiful cable with all the wires inside. With chips and stuff. You want this chip thing. You see only 2 wires inside. Hey, wait, what happened? 2 wires inside, you see? So, the red wire is probably the plus, and the black wire is probably the minus, unless these people thought to make a joke with us and reverse these cables. Anyway, let's put this in here. Right, so which one was which? Can you remember which one was which? So which one is minus? Minus, plus. Red goes in here. Red goes in here. And black, I don't like this PD controller thingy. The little one is the way to go, right? Looking for a good one? The little one. Looking for one that you can just use to test the charger? This is good. Otherwise, the little one. Now, what am I doing? Right, here. Let's plug this in here, right? Now let's plug this in here, and we force the adapter to give us the 5 volts we need. Now if I plug this in here, you see, now it's charging, you see, 440 millivolts. Now it's charging because we now have a PD controller in between the communication. You see, we have the charger, the PD controller. The PD controller speaks to the charger is like, hello, what you need? And this is like, I need 5 volts. And this is like, okay, so here you have the 5 volts, and it gives you the 5 volts. And the 5 volts comes here, and we're charging this drilling thing, right? Okay. Now, if we remove our invention from here and plug it like that, nothing happened. So we had the laptop charging for some time, couple of, I don't know, 1 minute. Let's see if it's charging up to come on at least. Is it coming on? Yeah, you see, nothing connected in here. You see, it's charging. Do we have any battery voltage? It's probably like 3% or something. It was like 2% about a minute ago, so can't be too far along. The battery is discharged, and the battery is 7% now. 7%. It's telling us that, come on, man, give me some juice. Let's turn it off and put it to charge. Right. Okay, let's put it to charge a little bit. That's it. Okay, so this was the video. I hope you found it interesting. If you did like it, please leave it a like, subscribe, leave a comment. This was about these PD controllers. I hope you have a better understanding now of what they do and practical uses for these little boards. I mean, these boards are amazing, especially this one. You see 30 degrees, this is brilliant. And this board, I think it was about €2 or something. I mean, come on, man, this is beautiful. Look at this, €2. Brilliant. Well, thank you for watching. I'll see you in the next video.